Integration by parts and U substitution are the two most frequently used integration technique. When you look at the integrand, it is usually written as the product of two functions. So let's take a look at the first integral. So this one is integral. We have x to the fifth times ln x dx. If you force to use the U substitution, let me tell you that is not going to work. So even though that makes the integral a little bit easier, you will still have to use integration by parts to solve the problem. So for the integration by parts, I wrote this as integral u dv equals to uv minus the integral of v du. So just don't spend like 5 minutes stare at this and then keep thinking, okay, what is this trying to tell me? Let me tell you how to do the integration by parts using these two examples. So the first thing that we will have to do is we have to select a u. So for u, we usually select something that can be differentiate very easily. So this problem, I will just select u equals to ln x, and then du equals to the derivative of ln is 1 over x and then dx. So this is done. And then right next to it, you will have to tell me what the dv is. So I already let u equals to ln x, and then the dv is the leftover. So which is the x to the fifth and then dx. So since I mentioned v in the integration by parts, then you will have to tell me what v equals to. So we have the derivative of v is equals to x to the fifth, and then therefore v is the integral of that. So v is equals to integral x to the fifth dx, so which is equals to 1 over 6 x to the 6. And then this is the preparation for integration by parts. Now, you might ask me, hey, can I do this? Can I just let u equals to x to the fifth? Because you said that you want u be something easy to integrate, right? Okay, so x to the fifth is also easy to integrate. So what is the problem of letting u equals to x to the fifth? So the problem is if you do that, then for the v, then you will have to take the integral of ln. Once again, if you let u equals to x to the fifth, then you will, for the v, you will have to take the integral of ln. I know you might be saying, all right, so in your previous videos, like in the past lessons, you mentioned what the integral of ln equals to. Yes, I did. I did mention what the integral of ln equals to. However, the integral of ln equals to whatever that is. So the way you get the integral of ln is you have to use integration by parts, which is what we are doing right now. So if you just write the integral of ln on your paper right now, you don't know how to get it because you just start learning integration by parts. So when you do integration by parts, do not write the integral of ln. So this is something that you will have to avoid. So once again, avoid writing the integral of ln. So regarding the integral of ln, I will show you how to do that after we finish these two problems. Okay, so back to our business. What is the next step? The next step is you tell me what the integration by part is. So from now on, let's just use by parts. So that is, by part is uv minus the integral of v du minus the integral of v du. So uv, you have that, right? So ln and the 1 over 6 x to the 6. So let's write this down. So 1 over 6 x to the 6. And then you have an ln x. Let's just go by this order. So you have ln x and then parenthesis x to the 6 divided by 6. So this is your uv, and then minus the integral of v du. So 1 over 6 x to the 6. And then the integral, and then du is 1 over x dx, right? And then this is, what is this? X to the 6. I would like to put this in this order, ln x, and then minus. So you have the 1 over 6, and then the x to the 6 becomes x to the 5th, and then dx. So now we can just integrate the x to the 5th very easily. So this is x to the 6 divided by 6 times ln x, and then minus. So this is a x to the 6. 1 over 6 times 1 over 6 is 1 over 36. And then you add a c to it, and then this is the answer. Now, what do you have to keep in your mind when you do integration by part? Number one, never put the integral of ln on your paper. Never. Number 2, have this preparation on your paper. I would like you to do the u on the left side and then do the dv on the other side. So when I was learning integration by parts, my professor told us that you should have these 5 lines ready. So 2 lines for the u and then 3 lines for the v. Okay, you should have these items ready, like put them in this position so you can do the dv, right? So dv and then integral of v du, so the integral of v du. So you look at the u dv like that, so this is your u dv and then integral of v du like this. Okay, so let's move on to the next problem. The next problem, I prepare a definite integral. For the definite integral, all you have to do is do a little bit more work. So this one, I will just let u equals to x and then du equals to 1 dx, and then v, I will just put that on the e to the x, so dv equals to everything else, e to the negative x dx, and then v is equals to integral of e to the negative x dx. Because to go from derivative back to v, we have to integrate both sides. So what is that equals to? That is equals to, you can put this on, you can do 4 lines if you want to. So e to the negative x and then you have to put a negative 1, right? Because when you take the derivative of that by chain rule, the derivative of negative x produces a negative 1. So you have to prepare a negative 1 to get rid of that. And then next, you recall the by parts. By part is uv minus the integral of v du. Alright, u is x, v is the negative e to the negative x. So we have negative x e to the negative x. That is your uv, but this is a definite integral. Then you have to do such that x goes to 0 to 4. And then minus the integral of v du. So the integral of v du is just 1 times dx, and don't forget that this is a definite integral. So this is not a u substitution. You can use x equals to 4 and x equals to 0. So we plug in when x is equals to 4, what do we have? We have a negative 4 e to the negative 4, right? So when x equals to 0, everything becomes a 0. And then plus the integral of e to the negative x, that minus gives you a plus. The integral of e to the negative x, that is negative e to the negative x. X goes from 0 to 4. So we have negative 4 e to the negative 4. And then plus minus, right? So you minus e to the negative 4. And then you minus a 0. You minus a 0. I mean minus e to the 0, which is equals to 1. Okay, so e to the 0 power is equals to 1. So I am going to change that to a 1. Okay, what else can we do? We have a negative 4 minus 1, right? So negative 4 minus 1, that is equals to negative 5. Then you can do a negative 5, like probably e to the 5th minus 1 if they do not accept negative exponent. All right, hold on. So before we end this, I would like to check something really quick, which is this. So we have plus e, right? So I would like to check this real quick. So this is a negative e to the negative 4 minus, you minus e to the negative 0. And then this is a plus. So that means this is supposed to be a plus 1, and this is supposed to be a plus 1. All right, so mistakes is fixed. So let me just, I will just keep that thing in here. Now, I just mentioned that do not put the integral of ln on your paper, right? Okay, what happened if I ask you to integrate ln? So what happened when I ask you to integrate ln x and then dx? How do you do this using integration by parts? So first of all, you will do this. This is equals to 1 times ln x dx, and then you use integration by parts. So give me some space over here. I'm going to move this up. For the integration by parts, I'm going to let u equals to ln x because I don't know what the integral of ln yet. And then du equals to 1 over x dx, and then the dv equals to 1 times dx, and then v is equals to the integral of 1, which is equals to x, right? And then you do a uv minus the integral v du, so uv minus the integral of v du, so that is equals to x times ln x minus the integral of v du, which is 1 over x dx. And then the integral of 1 over x dx is wait, hold on, uv minus the integral of v du, so the integral of v, the integral of v, that is equals to x, and then this is the integral of 1, which is equals to x. So you have x minus times ln x, and then minus the integral of x, the integral of 1, which is x, and then you add a c to it. So that's how I got the integral of ln. So these people usually do not consider this as a formula. So to get the integral of ln x, you will have to show the integration by parts. So that's why I told every one of my students, when you do integration by parts, never write integral of ln x on your paper. Alright, so that is the end of this video. If you like the way I teach by parts, give me a like, give me a subscribe, and I will see you all in the next video for more interesting examples. Signing out.